Student friends, in this talk under molecular symmetry and group theory, I am going to cover the two important basic terminologies of molecular symmetry. One is that the symmetry operation and another is the symmetry element. Now let us see the symmetry element. Symmetry operation. Symmetry operation is simply defined as the operation, either rotation, reflection or inversion, performed along a geometrical entity either axis or line or plane or the point or center in a molecule so as to obtain an equivalent or identical orientation from original orientation of a molecule called as the symmetry operation. So okay, whenever we are using symmetry as the prefix before this word, the operation, then symmetry operation means simply any type of operation operated on a molecule for getting either equivalent or identical orientation from orientation of a molecule. Means let us see best example is the water. We know that the water having the inverted V shape. This one is the oxygen, and these are the two hydrogen atoms. Okay, inverted V shape. So for sake of understanding, I have considered this hydrogen as unlabeled hydrogen and this H2 as another hydrogen as labeled hydrogen. Then let us see the imaginary axis. This is one axis passing through the oxygen atom. And if I am going to operate the rotation along this in the anti-clockwise direction or clockwise direction, and this rotation at 180, if I am operating the rotation along this axis and at 180 degree, I am getting the new orientation. Okay, this is the new orientation. Okay, in this new orientation, we know that the position of oxygen atom is as it is. Only change is that the labeled hydrogen is shifted to this labeled hydrogen shifted at the site of the unlabeled the hydrogen, and unlabeled hydrogen shifted to at the site of the labeled hydrogen atom. So I am getting this new orientation. And again, if I am going to see this new orientation is equivalent to this original orientation or this first orientation. Equivalent orientation means if you are going to see the framework of these two, framework is almost same. If I am taking this molecule and if I am putting here, the framework is almost same, inverted V shape. Only change is that the exchange between the like atoms. Then, equivalent orientation means orientation having the same framework to that of the original orientation, but there is exchange between the like atoms. Then because of the same, these two are equivalent to each other. So if you operate either rotation or reflection or inversion along a geometrical entity in a molecule, and if you are getting either equivalent or identical orientation means again if I am let us see this new orientation. If I am going to consider this axis, imagine axis passing through this oxygen, and if again I am performing the rotation, then I am getting the original orientation. Means this labeled hydrogen shifted here, unlabeled is shifted to here. So equivalent orientation means which is same as like the original orientation of a molecule. Means in terms of the overall shape, in terms of the overall framework of the molecule, as well as the position of the like atoms is almost same. Then such orientation is called as the identical orientation, no doubt. So symmetry operation means if you are performing any operation on a molecule, and if you are getting the either equivalent or identical orientation from original orientation of molecule, then the operation is said to be the symmetry operation. Then if let us see, if I am performing the rotation, let us see, instead of 180 rotation, if I am going to perform 90 rotation or 60 or 120 rotation, in all such cases, I'm getting the orientations, but these orientations are neither equivalent nor identical to the original orientations, because we are going to easily distinguish when we perform the rotation at angle 90, 120, or 60 with respect to the original orientation of the molecule. And because of the same, in such cases, we are not getting the identical or equivalent orientation. So in such cases, one can say that simply there is operation, simply there is rotation, not a symmetry rotation. Symmetry rotation or symmetry reflection or symmetry inversion means when you operate such operations on a molecule through a geometrical entity, we are getting either equivalent or identical the orientation from original orientation of the molecule. Then if you are going to see in this case the symmetry operation is rotation, and the element on which we have carried out the operation, that element is axis of rotation. And basically these are the elements and these are the operations, no doubt. So here symmetry operation generates an element. Thus symmetry operation and symmetry elements are strictly interrelated to each other. Means if you want to rotate a molecule, so before that you want to consider the axis or line passing through a molecule. If you want to reflect a molecule, before that you want to consider plane within a molecule. So if you want to invert a molecule, you want to consider point or center within a molecule. Means in another words, one can say that symmetry operation and symmetry elements, these are interrelated to each other. No? So one does not exist in the absence of the other one. Means for rotation, before that you want to consider the axis. Or if you are considering the plane, then at that time you want to operate the reflection as an operation. And if you are going to consider a point or center in a molecule, then at that time you want to operate inversion. So this is regarding symmetry operation. Then regarding symmetry element. Symmetry element is simply defined as a geometrical entity. That geometrical entity is either line or axis or plane, point or center through which operation is carried out. And what is the aim? Aim is to obtain either equivalent or identical or indistinguishable orientation from original orientation of a molecule. Then that geometrical entity is called as the symmetrical entity. Symmetry element. No doubt. So there are basically these are the geometrical entities, either line or axis, plane, point, or the center. So axis through which the rotation operation is to be carried out, the plane through which reflection is to be carried out, and point through which the inversion is to be carried out. So symmetry operation and symmetry elements, these two basic terminologies are very important in the group theory.